Euler's formula from 3D to 2D. Okay, so we're going to look at the formula V minus E plus F equals 2, which is known as Euler's formula. Where does that come from? And you might see many different rearrangements of this. It's all the same thing. You might even see old textbooks where they use R for regions instead of F for faces. But V equals vertices, and E equals edges, and F equals faces. Now, if we were to imagine a cube, and we don't have to imagine it for much longer because I'm going to draw it. Here's my cube, like so, and then we're going to dotty stuff for the back like this. All right, so you have a cube. Now, a cube is just like a dice, so you know the vertices for a cube, that's going to be the little dots on the corners. So how many corners does a cube have? It has 8. And then you can say how many edges does it have? Well, it's got, if you do count that, that's 12. And a dice, well, it's got 6 faces because that's how they use them in games. So 8 minus 12 is minus 4, plus 6 does in fact equal 2. Now, that's a 3D object, but you can actually do a thing where you just kind of like stretch and squash this cube and make it into a planar graph, if you remember what a planar graph is. So what we need to do here is use our imagination a little bit. So this is our front face here, all right? And what we're going to do is we're going to just stretch that out real big. So that face is now really big like so. And then you've got this back face here. See, that's the back face here. That's still there, small and in the middle. And that's still connected up. So it's still connected to the front face like so. Can we see that that is in fact the same shape? It's got the same thing. There are indeed, if you look like that line is this line, and this edge, sorry, not lines, edge is that edge, and that edge is that edge, and then that edge is that edge. It's the same diagram. Mind blown. Now, we said about the vertices, well, let's count those vertices. So you have indeed got 1, 2, 3, 4, 5, 6, 7, 8. Still got the 8 of those. And then we got our edges. We can count them all. We've still got 12. But let's think about the faces. 1, 2, 3, 4, and 5. So we do have, indeed, 5 faces. Wait a minute, it's a dice. It's got 6 faces. So you have to imagine if you're a person and you're standing on the edge here of this thing, that the 6th face is like all around you. It's kind of blocking your view if it was there. So you just imagine that the 6th one is on the outside, and so that's why you always include the outside as a face. Hope that makes it a bit more clear about where this formula comes from. There's lots of ways of looking at how to take 3D objects and transfer them into a planar graph, which has exactly the same connectivity. I'll put a link in the video description below.